Hello everyone, welcome. So, continuation of Microsoft Fabric. In this session, we are going to create a tables for the files that we already imported. As you look at the Lakehouse here, in the previous session, what we did, we imported the files. So let's look at the files here. So we have, let's look at the Parquet files. So if you look at here, so we have dimensions and fact tables that are imported in the format Parquet. So for these files, we will be converting these files into tables. So that is today's exercise. And let's see how we can leverage the notebooks to convert these files into Parquet, to convert these Parquet files into tables. So here are the notebooks that are attached to the lake house. So as we said, so we these notebooks are already attached to the lake house or one lake. We don't need to do any separate connections to the files or tables within the lake house. As you see here, so these are a snippet of the code in the notebook. So we are using a vorder and optimize writer. So vorder is it converts the data into columnar and it compresses for easy read and write. And optimize writer also gives the flexibility to write the data into partitions, and it optimizes for the read as well. So let's execute this cell. So as you see here, we don't need to attach this notebook to any cluster. This is a serverless service where the moment you start running it, it automatically establish the connection. So that's why it says serverless service, where you don't need to attach to any cluster. So and the next snippet of the notebook code what we have here is, so this code what it does is it's going to read the full fact file. So just give you a brief introduction. So we have one fact table and multiple dimension tables we have. So as we know, first we would create the fact table and followed with the dimension tables. So in this code, so we have the file location here, the files and whatever the location that you see, and it's in the Parquet format, and so it's under the full. So we have the fact sale file we have. For that, what we are doing is we are reading that file and we are adding a few columns here. So you if you see here, we are adding year, quarter, month columns. And so for year, invoice date key, and for quarter, so we are deriving year, quarter, month out of the invoice date key. And we are writing this entire data into a table. So the table name will be fact table. So as we defined here, and we are writing this data into a fact table. Let's execute this cell and see what happens. So the cell is being executed. So it may say take around 30 seconds or 1 minute. um, let's see, still it's running. So once the table is created, so it would be shown under tables here. Right now you have only dimension underscore customer table we have. And once this fact table is fact underscore sales is created, so we should be able to see under this tables list here. Now, as you see, this particular notebook snippet of the code has been executed, and you would be see this data fact underscore under tables. So we will have this partition keys year, quarter, month. So these keys are also added. And next we are going to create a dimension tables. So if you look at the dimension tables here, so let's so we already created a dimension underscore customer. Let's delete this particular one here. Yeah, we deleted that dimension underscore customer table. Now if you look at here, this code, what this code is doing is, so we defined table list here. These are the tables that we have: dimension underscore city, dimension customer, data, employee, and stock item. And we are looping through this, and we are calling the function that is defined here. So as we see here, it's the function it starts with a def, and it's taking the table as the parameter, and it passes this parameter inside this path. And so once the data is read for each table, it's going to create tables, like with each name. Okay, so this, let's see how this is going to. I believe this path is not accurate, so let me get the path, actual path of the file. So, and we are looking for dimension. So let me get the path here. So I would be like copy. I believe I should have here in the above code, I should have here. So I should be able to copy it from here. So full. This one I can copy and paste it here for dimensions as well. Since this path is available, let's run this code here. And obviously it's going to take some time. Yeah, let it execute. And we will see, once the dimension tables are created, so we will be able to see under tables here. If you look at now, this snippet of the code has been executed successfully, and all the dimension tables are created as we have in the list. So currently we have created facts and dimension tables. So in the next we have another notebook where we have where we are creating the aggregation tables. So I will explain in detail what we are planning to do. But for now, so far what we have seen, we have imported the files, and using those files we are creating the tables in delta format. So that is the exercise we have done. And in the I think, yeah, in the today's session itself, we are going to create the facts aggregate tables as well. So we can use two methods. One is either you can use Python or Scala code, or you can use, if you are not comfortable with using that code, you can even use the Spark SQL. So Spark SQL, if you are close to SQL, you can use the Spark SQL to create the uh, summary tables or aggregate tables as well. So let's look at those two options that we have to create aggregate tables from these delta tables that we already created. Yeah, we have another notebook as I mentioned. So we are creating two aggregate tables, and we are using two methods. One is the Spark SQL, another one is Spark Python code. So first one we are creating here is the table what we have here. It is the aggregate table, aggregate sales by date by city. So this is the aggregate table that we are creating, and here is the code. So we are using aggregate basically in the data warehouse, right? In the data engineering or data warehouse world. So we first load data into facts and dimensions, and we can create on top of those tables, we can aggregate the data. So right now in this particular example we are using two dimensions and fact table. So if we look at this data frame, so in this data frame what we are doing is we have fact sales is the you know this is the this the data what we are doing is we are joining sales, and this is the dimension we have, and city another dimension. So hey, sorry, I jumped a little ahead. So first we have to create these data frames. So as you see here, for fact sale, this is the data frame. We are reading Delta Lake table that is already created fact sales, and we are using other two dimensions, date dimension and city dimension. So we already got this data into data frames. So using data frames, how we are going to join and create aggregate table is the below code, and we are also adding a few additional columns in the aggregate table. So if we look at this, this is the data frame that we are new data frame that we are creating, sales by date city. So we are using the fact table as the driver table, and we are joining dimension date on the key here. If you see the invoice date key, so basically invoice date key in the fact table is equal to dimension table date. So this is the join criteria to join the dimension date fact. And similarly we are also joining dimension city using inner join. So if you look at here, so we already specified so what sort of join we are doing, and we are doing the join city on city key in both tables, dimension and fact. So these are the join conditions, and obviously we are selecting the columns, what are the required columns we need, and we are grouping by the criteria here, and we are summing up. So what is total excluding tax, total tax amount. So these are the aggregate column sums we are doing on, and then we are renaming each sum. So if you look at here, so we are renaming total excluding tax is sum of total excluding tax. So these are the sum of our aggregate columns, and we are renaming here as below, and we are also order by these. So this is the way we write the code, converting the SQL in PySpark. And finally, once this data frame is created, we are using the data frame to write data into in delta format in as a table. So table is, so we are writing under tables. As you see here, we are writing under tables, and the table name is aggregate sales by date city. So let's execute this one. It should be creating. Yeah, it's in progress. Yeah, this might be like, if you are not too much familiar with the PySpark or Scala, so it might be a little bit confusing, the code what we have here. However, it is pretty much same as SQL, but just the syntax is quite different, and the order of the way we write the code is slightly confusing. It's not that straightforward. However, it's not too hard to understand. So I just want to show you, like, two options that we have. So the second option also, I'm going to demonstrate how we can create aggregate table in a similar fashion. So now, if we look at, if we refresh this tables, so we should be able to see aggregate sales by date. So this table is also created. So now let's look at the other option that we have. So this is what we do here. We first create a temporary view. So, and once we create the view, and then we can use this view to create a table, final table. So this is the SQL, create or replace temporary view. This is the name that we have, and we are using fact table here. So obviously this is not our lake house. Our lake house is this one, lake house underscore demo. Let's change that. Okay, so we change the schema. Here we are using the fact table, and we are using dimension table and employee. So, and here are the, we are joining inner join and using the keys, and we are grouping by the columns here, date, calendar, so day, month, year, and all the columns here, and we are doing the sum of these columns, right? So once we do this, we will get this view, and once the view are created, what we can do is we can use this functionality again. So this above code, right, it's in the view. So using the select star from this view, we are creating the data frame. So using this data frame, again we are using the same method to write data into. So this looks simple and easy, if you are, like, familiar with SQL. So the above one, it looks a little complicated, but either one of them you can use, depends on your convenience and performance as well. So let's execute this one. Yeah, it should be executed quickly. Yeah, it's executed because you are just creating the data, so you are not actually calling it. So that's why it created within 2 seconds. Now once we have the data frame, we are going to, not data frame, the temporary view, we are calling this statement first. We are creating the data frame here, sale by date employee, and we are writing the data using this second instruction here. Let's execute this one. Yeah, probably it would take some time here. Let's see how much time it's going to take. So once this is finished, we should be, yeah, it's not too bad. It got created within 16 seconds. So if we refresh this tables again here, so we should be able to, yeah, another aggregate table that is created. So now we created fact table, dimension tables, and aggregate tables using the notebook. So hope you got something out of it. So we will continue working on these tables, and we will come up, or, like, we will build a project. So most likely I will be explaining what we are planning to do using these tables. For now, what I just want to conclude in this session, what we have done, we already imported files, and we all files, and those files we converted using notebooks into delta tables. So there are two methods we use to create aggregate tables. One is, like, PySpark, and the other one is Spark SQL. So to me, like, Spark SQL is clean and neat and easy to understand. So I would prefer to use it. Thank you for watching. Appreciate.